Photographic Exposure, Week 1. You have probably taken lots of photographs of many different things. Most cameras and telephones take very good images set on the point and shoot mode. But do you actually understand what is happening in order to expose the image? There will be times when you need to take images in challenging light conditions, or when you need a particular effect or type of image, when it is important to understand photographic exposure. Photographic exposure is the key to taking good images. Exposure forms the foundation stones of photography. All other skills are built on an understanding of exposure. Exposure at its most basic level is how light or dark the image will be. It is controlled by three things: aperture, shutter speed, and ISO, which stands for International Standards Organization. These are often referred to as the exposure triangle because they are all interconnected and the adjustment of one affects the other two. Let's start with aperture. A camera's aperture is basically a hole that lets light through your lens and into the camera. Early cameras literally were comprised of a box with a small hole in. With the development of photography, the aperture became adjustable. It can be made larger or smaller to allow more or less light into your camera. A modern aperture would normally be in the lens of your camera and is made up of a series of blades that overlap and together form a hole, as demonstrated by images 1 and 2. Aperture is specified in terms of an f-stop value. Rather confusingly, the size of the opening increases as the f-stop value decreases. This is demonstrated by the diagram at the bottom of this slide. f4.5 is the largest opening, or the largest aperture, and f27 is the smallest aperture. The f-stop is calculated as a ratio between the diameter of the aperture and the focal length of the lens. For example, with a 50mm lens, f2 is saying that the diameter of the aperture is 25mm. The ratio is 50/25, which equals 2. It is commonly thought that the focal length is where the f comes from in f-stop. A camera's aperture setting is also what determines a photograph's depth of field. Depth of field is the amount of subject matter in front of and behind your plane of focus that appears to be in focus. Depth of field is important to the quality of your image. Larger apertures, i.e. smaller f-stop numbers, produce a shallow depth of field, and smaller apertures, larger f-stop numbers, produce a deeper depth of field. This is demonstrated by these images. The image on the left has a small f-stop number, i.e. a larger aperture. So the focused area only covers the first head in the image. As the size of the aperture is reduced, more of the image comes into focus. In the third image, the first, second and third heads are all in focus. Broadly speaking, the better the depth of field, the better the quality of the image. depth of field is particularly significant in object photography. When photographing small objects close up, not all the object will be in focus, so the smaller the aperture, the better the depth of field you will get with this kind of photography. As a general rule of thumb, the closer you get to an object, the narrower the depth of field will be. So you need to have a very small aperture to try to get as much of the image in focus as possible. Moving on to the second element of exposure, shutter speed. A camera's shutter determines when the camera sensor will be exposed to the light and for how long. This is referred to as shutter speed. The shutter works like a curtain, opening and closing at a given speed to allow light into the camera. The shutter speed is expressed in seconds or fractions of seconds. The shutter speed has a direct effect on the freezing of movement in a shot. This table gives broad guidelines as to what shutter speeds are needed for what type of photography. If we're taking, for example, a sports shot where a person is moving very fast in the image, you will need a very fast shutter speed to freeze that person in the image. These images show us the different effects of shutter speeds on the freezing of running water in an image. A slow shutter speed of half a second in the image on the top left gives us a very blurred representation of the water. The image to the bottom right, which is taken with a fast shutter speed of 1/60th of a second, freezes the water in the image. A very important thing to remember about the shutter speed is that it determines whether you can hand-hold a camera or if you need a tripod. From a 60th of a second or faster, a camera can be handheld. Slower shutter speeds require the use of a tripod, or the camera will shake and the image will be blurred. The third element of the exposure triangle is ISO. The ISO speed determines how sensitive the camera is to incoming light. Expressed as an ISO number, for example ranging from 100 to maybe 3200 in a digital camera. Higher ISO speeds dramatically increase image noise. On the slide shown, the image on the right has a high ISO speed, which gives the effect of digital grain. High ISO speeds should only be used if the extra exposure cannot be achieved by another way, for example by using aperture or shutter speed, or if working in the studio by increasing the amount of light provided by studio lighting.